special right triangles. They're not all that special, but they kind of are. Hi, I'm Sarah. I've been a STEM science math teacher for over 20 years, and I am here to make math engaging and fun and not so scary for everyone involved. If this goes away, follow me on YouTube, Patreon, Instagram, Stan Store. Go back and let's do some trig and special right triangle. So trig is a relationship. Now, while we're talking about trig, I'm really just going to focus on right triangle trig, which is just kind of dealing with this kind of stuff. It's all based a lot on the Pythagorean theorem, but also trig is like the relationship between the angles and the side lengths of triangles. Primarily right triangles. But you can use these like law of sines, law of cosines to figure out things about non-right triangles. But when you're first starting out, when you're first learning, you've got a couple of things going on. Okay, let's do a quick little detour to special right triangles because it does lead into trig a bit too. So special right triangles. Okay, remember we talked about how like right triangles always have that same relationship, right? The Pythagorean theorem. Okay. So that means that there's also, it kind of like narrows your scope and narrows your options for like the angle relationships and the side lengths. So when you have a triangle, a right triangle that is 45 degrees and 45 degrees. So this is a 45, 45, 90 triangle. So still our longest side is going to be over here. So the special right triangle, when you have the same angle, that means that these sides are going to be congruent. So if these sides are both side length of X or A or 5 or whatever, right? Then my hypotenuse, if I were to solve this for using the Pythagorean theorem, you would end up getting that it's X root 2. Okay, it's X times the root of 2. That is the special right triangle. So if this is 1, you would have 1, 1, 1 root 2. This was 3, you would have 3, 3, and 3 root 2. Okay, that's how that special right triangle works. There's another special right triangle, which is 30, 60, 90. Okay, so this side is 30 and this side is 60. So 30, 60, 90. Across from the 30, this is where you would have your side length of X. Down here, it's X root 3. And then along here would be 2X. That's the relationship here. Between these are the special right triangles. Now, trig, I feel like takes it even like one step further, is that we know that this is always the relationship between these sides when it's 45 and 45 and 30 and 60, but there is actually always a set relationship with right triangles. And those relationships are the trig ratios. So the fact that when you have 45 and 45, that these two sides are the same, and this is that side length times root 2. Over here, you've got this situation, right? Yes, the special right triangles are nice and clean. These ratios are all nice and clean, but they're not really that special because trig ratios are all the same relationship, right? The trig ratio states, for example, there's a limit to triangle side length. So you can't have like a side of 1, a side of 2, and then a side of 12, right? They're not going to reach, okay? So the triangle inequality is saying that you have to have your two sides have to add up to be greater than that third side. So there are limits to what a triangle can be and what the side lengths of a triangle can be. Now, when we take that into a right triangle, there's even more limits on it, right? Because then if it's a right triangle, it also has to fit with the Pythagorean theorem, right? And then the trig ratios bring in an angle measurement to it, okay? So the trig ratios are sine, cosine. The three main ones are sine, cosine, and tangent. Okay. So this means that it's like the relationship. Okay. So sine, and then we use this symbol here, this circle with a slash through it. That's theta. Okay. So sine of theta is always going to be sine of this angle is the relationship, is the ratio between the opposite and the hypotenuse. Okay. And this is just off of a right triangle. Okay. If you say this is theta here, okay, this is the opposite. This is always the hypotenuse. And this side is called the adjacent because it's right next to that theta. Okay. So sine of theta, so the sine relationship of theta is the relationship between the opposite and the hypotenuse. No matter what the size of this triangle is, if that angle is a particular measurement, it's always going to have that same relationship. Okay, so just like no matter what these angles are, as long as it's a right triangle, it's going to fit into this relationship. Okay, so cosine theta is the ratio between the adjacent and the hypotenuse. And tangent theta is that ratio between the opposite and the adjacent. So SOHCAHTOA, yep. So SOHCAHTOA. One of my kids last year thought I said SOHCAHTOA. SOHCAHTOA, but we remembered it. So yeah, so sine is the opposite over the hypotenuse, cosine is the adjacent over the hypotenuse, and tangent is the opposite over the adjacent. Okay, so those are those ratios that are always going to be the same based on what that angle measurement is. Okay, they're always going to be the same. So again, like with those special right triangles, like yes, they have these particular relationships, right? But these relationships are really nice and easy to write out. A lot of the other relationships are not that easy or pretty to write out, right? There are technically 6 trig ratios, okay? So they're just the inverses of these. So sine of theta is opposite over the hypotenuse. CSC, which is cosecant of theta, is the hypotenuse over the opposite. Secant theta is the hypotenuse over the adjacent. And then cotangent of theta is the adjacent over the opposite. So these are the 6 trig ratios. These are the 3 main ones. And then these, again, like cosecant, secant, and cotangent, they just kind of match up with these 3. So the way that I remember the other 3 is that, so tangent and cotangent, those are kind of easy to match up, right? With the others, like sine goes with cosecant and cosine goes with secant, which feels super backwards, but it's also like, well, I'm flipping the ratios upside down, so I'm also flipping the names upside down. So it's kind of like you're flipping everything. But other than that, there's not really an easy way to remember it, I don't think. If anybody has like a mnemonic or anything, like I'm all for it. But yeah, that's just kind of the way that I think about it, is that you're flipping the ratio. So you flip, like cosecant doesn't go with cosine, right? Cosecant goes with sine. Secant goes with cosine. But that's just kind of how I remember it. That's mathed up.